Hello and welcome back. In tonight's video, I'm working alongside Westex Solutions Limited from Exeter, changing over lighting in a new sports hall. I save 16 balls from pending doom. 2 balls get completely destroyed. And we also upgrade all the control wiring for the sports hall lighting to bring it up to date. Just on my way over to grab a bit of lunch a minute, and those lights are proving to be very testing. You know, nothing about the whole mounting system is easy. We're having to mount the lights in probably like 8 different ways just because of how there's so many obstacles and things. The old lights were mounted on rod, but the old lights are nearly 3 times the size of the new lights and things like that. So yeah, I'm not gonna show you a huge amount of me actually mounting the lights. One, because I'm up against it a little bit time wise, and 2, because I'm not here to show you how to suck eggs. I just want to hopefully show you something a little bit more interesting. So I will show you the control side when I do that in a couple of days. So for now, this is me switching off and doing some, or many light things. End of another day. 10 lights up today, so that's 10 old lights down, 10 new ones up, which is actually pretty good going because it's bloody hard work if I'm honest. So yeah, got that one, that second row completely done. That one's half done. This one I've not touched yet. That one's all stripped off and half of the fittings are fitted. So making good progress. I've got, well, it's Wednesday now. We've got to be finished by the end of the week. So I got 2 days, and I'm most likely going to be here all day Saturday because I've got a conduit run to do from that door to that door. And then in here at the mains, let me flip you around. That rack and that rack are staying. Getting rid of all these terminals here, just literally using them as for the circuit breakers. So you've got a 3-phase breaker and a single-phase breaker from there. Single-phase feeds that one, 3-phase feeds this one. These are just going to be then individual breakers. Each MCB either does 3 lights or 4 lights, so it's all split down across them. So if there's a fault, it doesn't take out the main MCB and they lose all the lights. So we're going to put a big enclosure up here, which is going to harbour 16 contactors, so 1 contactor for each MCB. There'll also be 2 transformers because we're doing 24-volt switching, because we're going to utilise some of the cabling that already goes out there to use for the key switches. So we're going to use 24-volt key switches, which will bring in the coils of the contactors to turn the lights on and off. Because at the moment it's on a smart dimming system, but it doesn't work properly. So they want to get rid of that. And then, yeah, so nice. But yeah, another day done. It is now 10 to 6. I've been here since 7 o'clock this morning. But so yeah, pretty tiring days, not gonna lie. So it'll be the same again tomorrow, same again Friday, and same again on Saturday, more than likely. But yeah, I'll see you at some point tomorrow when we get more of this stuff done. Unless one of you wants to come and do it for me, because I'm sick of this. Being a busy boy, those 2 rows are completely done. That second row or third row from there is still to go. This one is, I've got 1 left to do. The trouble is, because of the type of floor we're on, that's why we've had to get a small machine. And I'm having to shift ply around everywhere I drive. My God, it is tiring. Chris reckons he can get this in from there. I don't believe it myself. Did it go in, Chris? Okie dokie, so what we've got on the MCBs here, you've got 2 lives coming out of each of them. These are the permanent lives that go to our emergencies. Those link through to the control pack in here, which is switched on and off by the low voltage switching cabling. All of these are our lights out. So what we're going to do is pull all these cables out through these bushes up into our new Schneider enclosure. And then we're going to pull a new feed from each circuit, from the same circuit breakers as those cables there, out, up to the incoming side of each of the contactors. We're going to bring a neutral up from each of the terminals here up, because they're common, they're completely common, they're open all the time. So it just means I can bring a neutral there, because at the moment we just got this 3-phase feed here. So I can bring a 1.5 neutral from each of those terminals up to each contactor. I need to then bring a main earth from there up into our new contactor panel as well, into one of the earth bars, so that I can join all of the lighting earth or CPCs into that. And then I need to do the same again with the single phase one, but they're all going to be in one contactor enclosure. So we'll have 16 contactors, and then we need some transformers as well, which are going to go in a separate enclosure. So the problem we've got is the transformers he's got only has enough volt amp output to power 2 coils. So we're a really tight time scale, we can't get the gear we need. So what we're going to do is actually have 8 transformers, 1 to feed each pair of the 16 contactors. Now then, to feed all of those 8, all 8 of those transformers will go through 2 more contactors like this, which in themselves will be fed by 1 more transformer. So you've got a 24 volt switching circuit feeding the first transformer, sorry, the first 2 contactors, yeah, which will power through with a permanent feed going into all 8 of the next transformers, giving a 24 output to all 16 of the contactors. So it's a bit of an arse around way of doing it, but it's the only way we can get it to work with stuff we can readily get hold of at really, really short notice in the deepest, darkest depths of Cornwall. So yes, but I'll start drilling out the holes here. There's going to be 4 25mm bushes there, 4 25mm bushes there into the trunking, and then I can get cracking and start putting all the singles in. So I've drilled just the pilot holes at the moment. So what I can then do, I've marked down through them with a Sharpie, which has transferred me 8 dots there, so I can use the pilot bit then, drill throughs with my 25mm hole saw on all 16 of those holes. Let's get them all done, and then I can couple it all together with brass brushes and galv couplers. Now, all the control wiring is mostly done in a twin core, or I think it's a 4-core, like shielded Belden. So they've all ran it. This is the existing wiring, which was done in 2008. It's all ran in the same trunking. We're going to have to use the existing cabling. At least it's shielded, so it's protected inside the trunking. But in an ideal world, they wouldn't have been running the same trunking system, because they're running separate trunkings up at high level. So it's just seems mad that they didn't do it all the way, really. But there we go. So yes, I'm gonna get that mounted. I think I'm gonna fit my second enclosure there, which just harbours all the transformers, along with the 2 additional contactors. But yes, get this mounted up, and then we can start pulling in some cables. Okay, it is about lunchtime on Saturday, so a lot has happened and you guys won't have seen a great deal. I'm certainly making a lot of mess, that is for sure. But first of the 2 panels is mounted, and I've started doing all the connections. So what I've done, I've removed all the old lighting circuits out of here and the old supplies, which I showed you a second ago in the video anyway. I've then pulled in a new neutral and CPC and a new live cable, which you can see each of these here, coming into each of the MCBs. They go up into the contactor panel. Okay, so so what you've got effectively is power from the distribution board to this main switch, which is isolated in the DB at the moment. From there into this buzz bar, which feeds into the MCBs. You've then got permanent lives from here, neutral net and CPC, up into the incoming side of each of these contactors, and on these as well. Okay, the lighting circuits, which were already there, are now obviously on the outgoing side with all the old numbers on them. I've kept them on there because it keeps it nicely identified. I would have marked up mine, but I do not have my stuff with me. And as I said before, I'm 2.5 hours away from home, which is really annoying. So, control circuit. Then we've got a 24-volt control circuit for all the contactors. Okay, what we're going to have is a series of transformers in a second panel identical to this next to it. And I'll go through with you how that all works once I've mounted it. So what I've done, I've moved this earth bar. Previously, they come with an earth bar mounted there and an earth bar mounted there. I've removed both of them. One is mounted here for this row of contactors, and the second one is going to get mounted here. So I need to do that in a moment. So all I've done is, these are the fixing points there and there. I've just ordered a 3.5mm hole into the metal plate and then used my M4 tap or threader, whatever you want to call it, tap them out and then refixed with the existing fixings. Okay, yeah, so looking a bit of a mess. It's not though, once the lid's all on, it certainly tidies everything up. So I'm gonna get that earth bar fitted and terminate all those CPCs and get the last 4 24-volt control circuits up for these ones. So what you've got, one 24-volt transformer actually does 2 contactors. So you've got the 24-volt positive coming in here, and then it loops across onto the A1 of the second contactor as well. So A1 is always your positive or your live. A2 is typically your negative or your neutral if you've got a 240-volt or even a 110 coil on your contactors. But yes, so I'm going to get that earth bar mounted and then finish the terminating, and then I'll show you me mounting and terminating everything in that next board, and then I'll go through with you how it all functions. Okay, so yes, it's a Schneider enclosure, and yes, we're using BG transformers. That is because we could not get Schneider ones in time. So these are Screwfix Special. So because these transformers are they only give out an 8-volt amp power on the DC side. So the trouble with that is only strong enough to pull in 2 contactor coils. I might have already explained this, I'm sorry if I have, but it's going to be easier for you to visualize it now. So we have 16 contactors because we have 16 lighting circuits. So what we've had to do, mains power into this transformer. Okay, I'm really sorry, I got distracted. Somebody turned up and then I completely forgot to do any more filming, and I just cracked right on. I'm not quite finished, but I'm nearly there. So, what I was saying, this is our main transformer. So what we have is a permanent feed just looping off of one of our lighting supplies. It's coming up through and it is feeding this transformer on the primary side and looping then across into the incoming side of both of our contactors. The outgoing side of those contactors, so for this one, it feeds the primary side of all 4 of those transformers. This contactor feeds the primary side of those 4 transformers, okay? So the problem was, one of these transformers was only powerful enough to pull in 2 of our contactors. So what we've essentially got now is a primary and a secondary control circuit. So our primary control circuit, that my phone is stopping. No, we're still filming. Somebody beeped at me. Yeah, our primary control circuit literally turns on those 2 contactors, which in turn turns on all 8 of our transformers, each of which turn on 2 contactors. It's a really rubbish way of having to do it, but it's the only way we can make it work with materials we could get easily in a really, really short period of time. Ideally, we'd have had a really decent Schneider or a Wago transformer, so a 24-volt transformer that has got a decent volt amp output that could have turned on and off the coils of all of these contactors, but realistically we couldn't get that in time. So we've opted to do this. Hindsight's a wonderful thing. And so is time, which I haven't got much of. So yes. So it's all going in pretty well. All I need to do now is loop my feed from my last transformer, just the neutral, sorry, into there, and then I can lid up. I've got a CPC going up here as well for the neutral link. Let's do that in a minute. And then it's done before I forget, because that's bound to happen, isn't it? But yeah, all round, I'm pretty pleased, considering we've made the best of a bad situation. And I am 100% certain any of you that work in control wiring will be shouting at me in the comments or at the screen saying, what an idiot. It's just over complicated for what it is. And you'd be absolutely right. But like I said, we're limited on time and struggling with resources. So this is what we're with, what we've stuck with. And it's going to work absolutely fine. If I can get the trunky lid on. There we go. Get them all straightened up because I'm a bit anal about it. Beautiful. There we go. 2 panels done. This trunky just sits weird. All I need to do is connect that in there now, do a few tests, and then I can actually power up the circuits and test the control wiring. Well, I need to finish the control wiring. Let me show you the control wiring. The switching at the other end. Oh. Okie dokie, so our switching. There was an existing switch point here. Wired in Cat 6, unfortunately. I would have much preferred it was wired in a Belden screened, but hey ho. We've then got another cable from there, looped up in the conduit in the wall, across the ceiling the other side of this wall, poked back out through in this galv conduit that we've fitted, run all the way across, and it's then going to drop down for another switch just there. Okay. Now, if I turn on this key switch here, let me see if I can hold you over that way while I do that. Come on. In theory, way. Why is that second row not come on? Ooh. Okay. So, half of that row didn't come on. It's the next day, by the way. Half of that row did not come on because one of my negatives had come loose in the contactor. So I'd replaced that. And it was at that point I then realised I'd made a very stupid mistake. It's been a horrifically long week, very long hours, and I'm very, very tired. And it was one thing I didn't quite think about properly. And that was that I was switching the neutral through my contactor. So what I've done this morning, took me 40 minutes just to go through. I've just literally whipped the neutrals out the top of the contactors and doubled them up in the bottom here. Because the trouble was, as soon as you turn the switches off, obviously you disengage the emergency pack. The live is still there, however the neutral was not. Or the line, but the neutral was not. So, silly mistake, hold my hands up, I've rectified it, this is it. There's no such thing as a problem if you're able to rectify it, okay? And all it cost me was a little bit of my time. So yeah, don't ever be ashamed to admit your mistakes because we all do them, especially when you're as overworked as I currently feel. But yeah. 2 panels are up, so you can see all the transformers here and things. Yeah, looking really smart now. These are all really good, humming away. We've obviously put a blank in between every single contactor and transformer. This is for heat dissipation because even though a contactor is effectively not doing anything, it is just a switch. All right, the coil, it does generate quite a bit of heat. So if you had all these bunched up, you want to make sure they've got space so they don't get affected too much by the thermal effects. Because they will have problems down the line if you don't do that. So yeah, always good practice to separate all your devices. Obviously, if this wasn't a modular enclosure, if this was just a regular enclosure where you had DIN rail mounted in it, you wouldn't necessarily have to have a blank as long as you just had an air gap. So yeah. Right, next thing, I want to get all these lids chucked on. I've got a bit of labelling to do here, and then I've got to do this last row of lights. So I'm going to get on and do that, and then this one will be wrapped up. So yeah, those 3 rows are switching as they should do now, with the emergency pack staying on, so thank God. And there we go. '56 light fittings changed over. What a horrible job. 24 volt switching, old dimming racks repurposed just as essentially distribution boards for circuit breakers, and then 2 panels which you've obviously seen, one with all the contactors, one with the transformers and the primary contactors. So yeah, didn't get to show you too much, which I'm really sorry about, but I've just been really up against it, I'm not going to lie. It's taken me longer than I was hoping it would have, but it has been an absolute mammoth job. So let me know in the comments how much you think I charged for this, and make sure you like and subscribe, and I'll see you guys very soon.